In this video, we're going to discuss the conversion of an alcohol to a sulfonate ester. In this reaction, an alcohol, which is a relatively poor leaving group, is converted into an alkyl sulfonate, which is a very good leaving group. The reason why an alkyl sulfonate is a good leaving group is because the negative charge can be resonance stabilized, as shown in these resonance structures. For reference, the slowest leaving group, which is fluoride ion, has a rate of approximately 10 to the negative fifth, whereas the fastest leaving group, the trifolate, has an approximate relative rate of around 10 to the eighth.
The first step of the mechanism is a nucleophilic attack by the oxygen, as can be seen here on the electrophile, the sulfur. The reason for this is the oxygen has a partial negative charge and the sulfur has a partial positive charge because of the electron withdrawing groups here and here, as well as here. Now, oxygen attached to a hydrogen is a poor nucleophile, as we know, so this will come into play later. This example we use is a tosyl group. Other examples of the sulfonate esters are the mesyl groups and the trifolate groups. So after the nucleophilic attack, the pi bond here will resonate up to one of the oxygens, as can be seen here. The next step is the movement of the electrons back onto a pi bond and the expulsion of the chlorine as a leaving group. Now, as we know from previous experience, chlorine is a good leaving group, but better leaving groups would be bromine, and even better would be iodine, because these are stabilized by having a larger size in total. Now, after the chlorine is expelled, the next step is the use of pyridine as a base to remove the acidic hydrogen and the formation of our final product. This step could also be used with other bases, as pyridine is just an example of a base. In addition, the stereochemistry is preserved. For our final example, this sulfonate ester can be used in every SN2, E1, E2, and SN1 mechanism that we have learned before. It just depends on what reagent is used next. And the reason for this, as stated before, is the sulfonate ester is a good leaving group because of the resonance structures. So it can be used in a variety of reactions.